Hi everyone, we're going to graph this piecewise defined function. The first thing we're going to do is test for continuity at x equals 1. So let's get started. To test for continuity, this is our definition. Our function must meet all three conditions. So we're testing if it's continuous, the piecewise function is continuous at x equals 1. This is occurring right where the graphs are changing here. So basically, that means our C equals 1. So the conditions must be met in order. So if condition 1 doesn't exist, then you don't need to move on to the other conditions. So we're just going to see if f of 1 can exist. So we do have an equal here, so we can put it in this function here. So we have 3 times 1 minus 2, and that equals 1. So condition 1 is satisfied. Now we have to do condition 2. Condition 2 means that the left-hand side of 1, which is this part, should equal the right-hand side of 1, meaning the numbers on the right of 1. So basically, you have the limit as x approaches 1 from the left. That should equal the limit as x approaches 1 from the right. Numbers bigger than 1. So we already know that from the left, numbers smaller than 1 here, that was 1, because we already plugged that in. From the right, we're going to plug this one into this equation, and that would be f of 1 equals 1 plus 2. That means that equals 3. Therefore, 1 does not equal 3. That means condition 2 is not satisfied, because these two don't equal. That means this limit does not exist. Doesn't exist. Therefore, this function is not continuous. It's going to have some discontinuity to it. Alright, so let's graph it and see what's going on. So our key area that things are happening are at x equals 1. That's our C. So from the left, all the numbers left of 1, we go ahead and plug in 1, and we already knew that was 1. And it can equal that. Alright? Now, my y-intercept is also negative 2 here, so I can plug that in. Since it is linear, I just have to plot 2 points, and that's going to go something like that. Just sketch it there. Now, for the numbers right of 1, we're going to do the graph right of 1. So, plug in 1, and at 1 we went to 3. So this is 1, 2, 3 right here. But it's open, because it can't equal 1. Then let's go ahead and plug in 2. If you plug in 2, you get 2 plus 2. That's going to be 4. You only need 2 points to make a line. So it's something like that. And this is why the function's not continuous. Because when you draw the line, to get to the next part, you have to raise your pencil up to draw the other part. So it's discontinuous. This is called a jump discontinuity. I can't spell. Continuity. And this is because condition 2 failed. Okay? And that's it. Thank you. Have a nice day. Bye-bye.